All right, let's go ahead and take a look at what happens with a secondary amine. And in this case, we're really looking only at carbon as our R groups. We're looking at a secondary amine, which will be, it'll have two R groups. They can be the same, they can be different, doesn't matter. For example, you can have something like ethylmethylamine. Ta-da! That's a secondary amine. We're going to see that with a ketone or aldehyde. Let's use an aldehyde this time. Under the same conditions, we're going to need a few more. There we go. Under the same conditions, we're going to get something different this time. We're going to get what's called an enamine. So it's an alkene and an amine. So enamine. For example, I'm going to move this one out of the way. It's just an example of a secondary amine. We get an enamine instead. The reason for this, as we will see in our mechanism, which is, by the way, identical to the last one, except for the last step. We have no protons to remove after the last step, but we're going to do something a little special instead. So we'll see that. Let's go ahead and let's use this example of this aldehyde, and we'll use our ethylmethylamine, because why not? So, just like before, if we have our ethylmethylamine, I'm going to move that H out of the way, just so we can very clearly get that lone pair in here. Go ahead and pop open your aldehyde, or ketone, in this case is an aldehyde. We end up with the O-, and the amine positively charged. We still have our H there. Just like before, we're going to have our protonated amine species, which has grabbed a proton from our catalytic acid, whatever that is, HCl, tosylic acid, sulfuric acid, whatever it happened to be. We'll go ahead and protonate that alkoxide. And we will now have our protonated amine, which I'll draw with a slightly longer bond there, and then we'll have our hydroxy group. So just like before, our amine comes along, and it's going to deprotonate the protonated nitrogen there, which will give us our carbenoylamine. That's kind of, again, remember, our hemiacetal intermediate. Although, since it's a nitrogen, we call it the carbenoylamine. So, that's our neutral intermediate there, after the proton shifts have happened. And so, just like before, we're going to want to go ahead and protonate our hydroxy group so we can eliminate it. I'm going to just move this down just a little bit so we can bring in our protonated amine. We're going to have our hydroxy group go ahead and pick up that proton, and we're going to move the electrons up to the nitrogen, just like before. We have our leaving group ready to go. And just like in the last mechanism for the imine formation, we're going to kick out that water by closing down the nitrogen to form a double bond. And this is the point where we finally get something different. So here we now have positively charged nitrogen, but nothing to do, we can't remove any protons from this directly. And so what happens is having this protonated nitrogen, which is now extremely electronegative, is going to really withdraw electron density away from that, what used to be the carbonyl carbon, And that's going to end up making this alpha proton quite acidic. This is something that we're going to see later on as well. And so our amine now is going to go ahead and grab off that alpha proton, and we're going to go ahead and form a double bond there and push these electrons up to the nitrogen. And in doing so, we will have now made our enamine. So we are left with our enamine here technically. And also technically, because of steric reasons, we're probably going to end up with the methyl group, since these happen to be an asymmetrical nitrogen. We want it to be on the other side. So, and again, we may see that that other methyl group may point down. We'll see E and Z enamines happen with different conditions. So just technically speaking, we often will get the Z one, the one that is cis, as it were. So that is pretty common to still see the Z enamine, and we can focus on that in our next video. But for right now, we just recap the mechanism. So secondary amine, acidic conditions with our carbonyl compound, displaces the oxygen and we form an enamine. So we have an alkene and an amine on the same carbon, a vinyl amine essentially. First step, nucleophilic attack. Second step, protonation of the alkoxide, which then we're going to remove a proton from our nucleophile, forming the carbinolamine, protonate the hydroxy, kick it out, and then we're going to remove an alpha proton, which leads to our enamine. And so here we have it. In our next video, we'll take a look at some of these stereochemical outcomes as to why we get E enamines and Z enamines.